Okay, I'm going to be working some of the logarithm problems from the study guide. I'm going to start with number 78. On number 78, the question tells you to find the pH if the hydrogen ion concentration is this given amount. It's written in scientific notation, but we're given the pH formula in the problem. So this is not something you have to memorize, but pH is the negative log of that hydrogen ion concentration. So all we have to do is pop this value into the formula, and it will be pH equals negative log. Instead of this is now substituted with that value that's given. And that can be directly typed in your calculator. You just hit the negative log, it's an understood base 10 log, 5.4 times 10 to the negative 11, directly on your calculator. There's other ways to work it, and if you looked at the MyLabs Plus problems, it may show that you could use the properties to expand this, but it's not necessary. You can directly just type it like it's written. So let me do that quickly for you, and you can check it on your calculator as well. And I get pH equals 10.2676, yada yada. It says to round, it will tell you what to round to. This one, it looks like it's round to the 10th. So this 2 is in the 10th place, the 6 would round that up, so we would have 10.3 for the pH, number 78. Okay, number 79. 79 is also an application problem with logarithms. It has to do with earthquakes and how they record those on the Richter scale. We have also a formula given. Richter scale formula is log, and it shows it's a base 10. That's always understood though, whether they write it in or not. It's understood to be base 10 of the intensity divided by the reference intensity. That is our formula. In this particular problem, it says an earthquake was recorded with an intensity that is 31,623 times more powerful than the reference level earthquake. Reference level is that I sub 0. That means that's what their initial referenced amount is. So this one is 31623 times that, more powerful than that. So we want to say it's 31623 times reference level I sub 0. So that is the intensity, equals the intensity. And you get that from the reading. Then that goes in the formula for I. So the problem becomes log, and for I we write 31623 I sub 0 divided by I sub 0. And then it's a calculator problem. The I sub 0's can be canceled out. So it's log, and it's a base 10 log, so we don't even have to write that in. And then we type that on our calculator. Directly on our calculator, log 31623 equals 4.5000. It tells us what to round to. I do believe, yes, to the tenths as well, so 4.5 is our solution for 79. Okay, number 80 says use the change of base rule. So what we need to know is what is change of base. Change of base says if you're not doing a direct base 10 or base E log, then you don't directly hit this in our calculator unless you might happen to have a little subscript button to do so. But it's not too bad. The change of base theorem is pretty quick. You just take the log of this argument divided by the log of the base. You can do this with your log base 10 button or your ln base E button. It would work with any base log to do the ratio, but it's just the ratio of those logs. Log of 2.6 divided by log of 5.8. Again, calculator. Using your calculator, very important on this chapter. So get your calculator that you're comfortable with and practice these problems. And I get 0.543565 long irrational number decimal. The direction should tell you what to round to. Here it looks like we're at 4 decimal places. If you're at 4 decimals, that's 1, 2, 3, 4 places after the decimal point, you'd need to look at the 5th place to decide whether to round up or leave it alone. The 5th place is a 6, so that rounds that up to a 6 for your final answer. And that would be rounded to 4 decimal places. Okay, number 81. if f of x equals 5 to the x, that's the function. It says find f of log base 5 of 4. So we've learned in the function notation section that when it says f of something, that means you plug that something in for the x, so that becomes the x value. So it'll be f of x equals 5. Instead of x, we put this value in, log base 5 of 4. And then we simplify that. You could type that on your calculator in some way, the right button pushing, but it actually reduces easier than that. We have a logarithm property back in our properties we studied that says you have a base and a log of the same base. These two cancel each other out and brings down the 4. So this simply is just that 4 for the final answer. Reduces to 4. Okay, number 82. Okay, so on number 82, we start with actual equation solving. There's no way to make 5 and 10 into like bases. 5 times 5 is 25, but it has to be something times itself as far as bases go. There's really no way to make those like bases, like we did in the earlier section. So what we need to do is take the logarithm of each side, and that will bring this exponent down as a multiplier. You can take base 10 log, which is the regular log, or the ln log. In this particular one, I would take the log log, base 10 log. It'll reduce a little nicer, but you can use either one. By taking the log of each side, which we're allowed to do, is keeping the balance, that makes any exponent now a multiplier. So that comes down in front of that as 2x minus 1, and it's times onto log 5. This side had no exponent to bring down, so it's just log 10. Now you could reduce these logs on your calculator. A lot of times they come out not perfect, so they're long, kind of messy decimals. So we don't reduce them until the very last step to keep it perfectly rounded, to keep round off error. But log 10 does reduce to just 1, so that I would go ahead and reduce to, since it comes out even, that is 1. The reason it's 1, well, you can check it on your calculator, log 10 equals 1. But the reason it is we know this means base 10 raised to what power is 10? So 10 to the first is 10. That's why it's 1. But again, you can check that on your calculator, see that it's so. Over here, we need to distribute. This is some multiplier, so it distributes into that parenthesis. So 2x times log 5 minus 1 times log 5 equals 1. Once you do that, it's really just old algebra for us. We're going to, just like we manipulate any equation, anything that's added or subtracted, we can throw to the other side, get the variables on one side, numbers on the other, and that is just a constant, just a number. So the variable term stays on the left. This moves to the right. Don't forget you've got plus 1 there. And then everything around our x is multiplied, so we divide. We divide off the 2 and the log 5, leaving our x alone. Do the same thing to this side. And then we've got to get that off our calculator. You need enough parentheses. That's usually the trick on these, is making sure you plug it in right to your calculator. Your calculator needs to know where this major division bar is. Unless some calculators have another way you can do that. But just a typical everyday calculator needs a parenthesis around all the numerator and a parenthesis around all the denominator to help it know where the dividing line for the main division is. So you would type it in, and this one is not critical. 1 times something, you don't have to show. So you can say parenthesis, log 5, close that parenthesis, plus 1, close the top. Divided by, open up the bottom, parenthesis 2 times log 5, close, close. That's how you need to type that in to your calculator. It's probably not going to come out perfectly even, so you'll need to watch your rounding always. The answer key says, number 82, if you have an answer key on these, you can always be checking your work, is answer B. So B, which is 215. How do we know for sure that's the correct answer? You can plug that back into the original problem, and I'm encouraging you to do that. So I'd say the original problem, what did it look like before? So here's the original problem. We can say it's 5 to the 2 times x 1.215.